Good morning. This is your stat sensei, Mr. Spensei, and this is a warm up. And we're going to be creating a confidence interval from the computer printout. So our scenario is big O failure. Random samples of earlier launches indicated that space shuttles experienced from 0 to 3 O-ring failures. There was some speculation that the number of O-ring failures was related to the temperature at liftoff. A computer printout performed after the Challenger disaster is shown below. Obviously, the most important line is our constant line. This is our y-intercept line, and this is our slope line. Those are our two most important lines. We find constant, we find slope. We never know where constant is going to show up. And we're supposed to be creating a confidence interval, and we notice we have a negative slope. I'm going to detour for just a moment. Because this is negative, I know my correlation coefficient will also be negative. Not that we're being asked about the correlation coefficient here, but because this is negative, the correlation will be negative. So here it goes. Use the computer printout to find the requested information in the table below and create a 98% confidence interval. That's going to be important for us. And the formula for the confidence interval is B plus or minus T star SB. Well, we're going to need to identify our slope, and we're also going to go ahead and take the time to identify our SB. Okay, our slope is right here. Standard error of the slope is right here. So there's our B and our SB. Once again, please make sure that you have written that as a negative slope. And there's the formula that we talked about. And that's where B is slope and SB is standard error of the slope. Now, please be careful. This is T star. That is not the same as this. This is a T statistic. We do not use that value here. We need to, well, use T star, and we'll actually have to calculate T star. So the one other thing that I'm going to need is my degrees of freedom. And my degrees of freedom is right here at 21. We'll need that. And we're going to go to the calculator. And we're going to go second vars, inverse T, parenthesis 1 minus, we want a 98%, so 0.98, close parenthesis, divided by 2. Degrees of freedom is 21. All right. That's negative, but we're positive people, and we turn negatives into positive because that's who we are. So there's my confidence level at 98. This should have said degrees of freedom being 21. So that's a mistake that we'll need to address, but that's degrees of freedom of 21, which we have here. And there's a 2.5176. Okay. We're going to go ahead and plug in and be careful. Once again, this is our slope, our negative 0.06, and that's our slope. This is our T star, and this is our standard error of the slope, which we also refer to as SB. All right, so that's SB in the formula, and that came from right here. Excuse me, SB came from right here, and there's my actual slope. All right, when we go to plug in, we're going to need to plug in, because that's the next thing we're going to do is our lower bound calculation. So we'll go ahead and plug into the formula that we have right there. And we'll have negative 0.062658.7, and we'll do the minus first. So minus 2.5176 parentheses 0.02016 close parenthesis. And when we do that, we're going to get a lower bound of negative 0.1134. And that's just putting in what we had, where this is my slope, this is my T star, oops, T star, and this is my standard error of the slope, or SB. So B plus or minus T star SB. Now we're going to do the same thing, except we're going to have to change that negative to a positive. So we're just going to scroll over, change that to a plus sign, press enter, and now we have a lower bound. So I always want to remind myself this is my lower bound, and I subtracted, this is my upper bound, and I added. Okay? And once again, those both came off the calculator. Hopefully that helped, and look forward to seeing you on the next one. Thanks for watching.